Hello, welcome back. In this lecture, we are going to go over chapter 9 about abstraction. So we are going to discuss abstract classes and interface. So this chapter again, this chapter is chapter 9 about abstraction. Yeah. So the topics in this chapter we are going to discuss include define and using abstract classes. Following that, we are going to discuss how to define and use interfaces. And then we are going to take a look at every list from Java Collections framework. Okay. And then we are going to discuss how to use the predefined interface from Java library, and those are used quite often. Okay, the clonable interface, comparable interface, and the comparator interface. Okay, those are very important. Okay, so the first section in this chapter is about abstract class. Okay, and this, so if you recall, previously we learned classes and we also learned the relationships between classes. And so far, our concept or in our memory, we know that you can use a class to create an object with the class's constructor. So we all know that, okay? Or we call it create an instance of the class. So if you recall, the class that we learned is about like the person class and outfit class. We also learned the animal class, a pet class, and a wildlife class. And if you recall, we use all of them to create objects through the new keyword, okay? And all of the objects are created on heap. Okay, and if you recall, when we use new to create object, we call it dynamic class. And we also have a static reference, if you recall those concepts, okay? And so all of those person outfit that we have learned before using new to create an object. So those class, basically, they are concrete classes. Okay, so concrete class can be used to create objects. Okay, and if you recall also within the concrete class, we have two kinds of um, the methods, member method, instance method. And the instance, if you recall, they are fully implemented. Okay, and we also learn static methods. And they are also fully implemented. Okay. So those are called concrete class. So the key concept for concrete class is, so concrete class can be used to create objects. So this is the key concept. So in this chapter, we will learn another concept. It's called abstract concept. So we kind of can get the idea, is it abstract versus concrete is, so they cannot be used to create objects. So they cannot be instantiated to create objects. Okay. But they can have instance variable and static variable. They can also have those, so the method that's implemented, well, this is in concrete class. Okay, implemented, fully implemented, we can also call them concrete methods. Okay, so abstract class can also have concrete. So then you may ask, what's the difference? Is it so for concrete, for class that's to be defined as abstract class, then there is one rule that must be met is it must have one or more member methods, the method be abstract. So not just a concrete method. Okay, so abstract method. So what is abstract method? So abstract method is not implemented. They only have an empty header. Okay, but no implementation. So that's the concept. So now we see abstract class, yeah, it has quite a lot of similarity between abstract class and concrete class. The difference is abstract class cannot be instantiated to create objects, and abstract class must have abstract method. So the method that's only have a header but not implemented. So that's the key idea. Okay. Okay, then you may ask, is it, if you recall the relationship so far we learned, we have the has a relationship, so that's the aggregation relationship. We also have that is a relationship, that's inheritance relationship, is it? So abstract class also allowed to have inheritance relationship. So the subclass, it can be concrete or abstract. Either way is okay. Okay. So if the subclass is concrete, then it must override and implement all of the abstract methods that they inherit. So that's if it's concrete, you must override and implement the abstract methods. Okay. And abstract class can also have another kind of, so later on we are going to learn another kind of method, okay? But so abstract class can also have constructor, even though they are not allowed to create object, but they can still have the constructor, okay, default and explicit value constructor. So they are allowed. And because abstract class cannot be used to instantiate it to create object, but subclass, it's a concrete subclass can create objects, is it? So when the subclass to create object to be instantiated to create object, they need to invoke the constructor, is it? So its own constructor for the concrete subclass, they can call its superclass, abstract superclass constructor. So that's allowed. Okay. So here the idea is abstract constructor can be called in concrete subclass using that super call. Well, let's take a quick look, okay, about the syntax for abstract class. And as usual for all of the class, need to have the visibility, okay, that's a public, private, protected, or without is a package private. But for abstract class, you need to have this keyword abstract to indicate that the class is abstract. The other part is the same for the header parts, okay? And for the variable, then you can have same thing, you need to have the visibility, then instance or static instance variables, okay? Static or instance variables, and also the visibility. And then constructor, same thing, visibility, okay? And then the instance method, that same thing, visibility, okay? And it's also allowed to have a static method and default method. Later on, we are going to see, okay. Oh, no, not here. Not messed up. It's about interface. So static method also allowed in abstract class, okay. And let's take a look at the last line in the syntax. Okay, so here for this method, if we take a look, we have the semicolon, so no implementation here. So it doesn't have the curly brackets block, okay? No method body block. And it also has a keyword called abstract, okay? So basically, this is just a method header. So empty without implementing, still has visibility. So this method, we call it abstract method. Okay, so an abstract class must have at least one abstract method, otherwise not. So then you may ask, why do we need an abstract class if it cannot be used to create objects? Yeah, it's because if you recall the inheritance in that relationship. So because if you have some method that's not implemented, it provide more flexibility for the subclass to do its own implementation. So it's provide more flexibility for the achievement of polymorphism. Okay, then let's do a comparison between abstract class and concrete class. Okay, for the keyword abstract class must have abstract. Instance or static variables, yes, both have. Okay. Instant static method, yes, both have. And for instant method, it may be abstract, okay. Constructor, yes, okay. And so constructor, not like concrete class, it will not be directly invoked. So it will be only invoked by concrete subclass through the super call, okay. Can be instantiated? No. And this concrete is yes. Can be extended? Yeah. Can provide inheritance relationship? Yeah, yes. And also concrete subclass must override and implement all of the abstract method. Okay. So that's the difference between these two. So basically, abstract class provide more flexibility for the polymorphism, okay, through the implementation of abstract methods. Okay, and then let's take a look. If you recall, in previous chapter, we discussed that animal class. Okay, as that it's a concrete, and if we want to rewrite as abstract, yes, we can do it. Is it? So in this UML diagram, you can see a majority of the instance methods and the variables, instant variables or static variables are same as the previous one. But here we do have a difference is we are going to uh, define the it method as an abstract method. So this is going to be an abstract method, okay? And if you take a look over here, okay, so this animal class is abstract class this time, okay. So pet, same thing. So we have refuse, it's a concrete class, is it? And so we have this object, so refuse, but over here, see, we can use animal to define our variable. So this is a variable, okay? The refuse as an animal, but the type, data type, reference type, you define it as an abstract class type. But you see, you can still assign it to refuse. This is the object. This is fine, okay, because this means that is a relationship. So this is a dynamic class. And this is static type. Okay, so it's fine, okay, to a variable of an abstract superclass. So this is allowed. Let's meet the is a relationship. Okay, and if you recall, in the previous section in abstract class, we learned abstract method. So abstract methods is method not implemented. Okay, and in Java, there is another very, very important concept. It's called interface. Okay, so it's not a class. We can use a class to instantiate, to create objects. Okay, and generally speaking, uh, um, uh, when we have class, it's represent a category of objects. Okay, so they share some common properties, features, and behaviors. Okay, and but in the real world, a lot of time, you also want to do something to kind of group related methods. Okay, under one umbrella type. So so it's a group of operations. Okay, behaviors. There are some related. So they kind of related, and you want to group them together, okay, under one umbrella type, and allow the implementation of those methods vary. So provide polymorphism. This is kind of also okay. So how do we do that? Is it and so in Java you can do that through interface. Okay, so this is another concept, it's interface. So here the group related method under one umbrella type. Okay, but the purpose is not to create inheritance relationship. So without creating some inheritance relationship, but they share methods. So the core concept is even different category, different category of objects can share using or leveraging this umbrella type. So that's different. Okay. If you recall, for inheritance relationship, they must be the same category of objects. Category of objects. Okay. And the category, at least, through the super class, etc. Yeah. But for interface, then it's not, it's different category. They can also share. Okay. Okay, so let's take a look more. Okay. So in Java, so the interface, okay, it can contain method signature. So this is same as abstract method, okay? So similar, so contain only method signature. So without implementation, so no implementation, okay? And classes, so both abstract and concrete class, we already learned, is it? Then they can implement an interface by providing the implementation of the interface method headers. And for abstract, then, if you do want to keep the method as abstract, then you even don't need the implementation, okay? But anyway, class can implement interface, okay? And also, different class, they can leverage, they can implement same interface. So different classes can implement the same interface. Okay, but so this is the concept that again uh, plays the role into, okay, very important role. It's polymorphism. Okay, so polymorphism is, but they can choose the different method implementation. Okay, so the way you implement can be different. Okay, even though they all implement the same interface, so that it allows software engineers to flexibly control the dynamic behavior of programs. Okay. So that's why we say it's object-oriented programming. Okay, so again, for interface, it also serves a role in the object-oriented programming for the polymorphism. Okay, so if you recall previously, we learned the relationship between classes is we have that has a relationship and is a relationship. Okay, that's between classes. And now we also have interface. Then, so what's the relationship between class and interface? Okay, so then we have a new method we call the realization relationship. Okay, so any class that wants to use the interface method and implement the method that they can implement the interface. So this relationship, we call it realization relationship. And in UML diagram, so if a class implements an interface, so you draw the arrow from the class to the interface, but with dashed. Okay, not like inheritance from subclass to superclass. It's the solid arrow. Okay. So it says descendants of a realization relationship because you realize it, okay, and the class implements. So class implements the interface. So it also satisfies is a type for polymorphism. Okay. So it still meets the is a relationship. Okay. Later on, we can see in our coding example. Okay, so interface, let's do a quick summarization. Its definition is it contains a list of, be careful, okay, method signature. It also contains static and default methods, so they are implemented. And they can also allow constants. Okay, so relationship, while more abstract concrete class, so class can implement one or more interfaces, not just one, okay, one or more interfaces. This is different from, if you recall, for inheritance. Inheritance only allows one superclass. Okay. An interface can extend can extend one or more parent interfaces. For class, there is only one parent class, okay? But for interface, it's different. It can extend one or more, okay? Can have multiple inheritance relationship. So when do we use an interface? So if we want to allow the flexibility of polymorphism without creating inheritance relationship. Okay. But through the polymorphism, then we can use interface. So how do we define an interface? And when we define interface, we can have quite of optional, okay, like the visibility, okay, some of the keyword like public, it's optional, it's not mandatory. And even though you don't provide that indicate it's public, okay, but you need to have the keyword interface then following the name of interface, okay. And then we can have method signature, okay. So in method signature, public and abstract, these two keywords are optional, okay. And the return type and the same thing, it's just a method signature. And the constant we can define. Okay, you need to specify type. And these three keywords, they are all optional here. Okay, public, static, and final. If you don't provide, and the program will know, okay, they are public, static, and final constants. And for static method, the public keyword can be optional, okay, but you need to have this keyword static, and you need to implement it. And there is a new kind of method, default method. Okay, keep this in mind, default method. We haven't learned before. So far, we learned instance method and static method. Okay, so today we learn another one called default method. Okay, and instance method must be implemented as it and with object. So using dot. Okay, class static method also called class method. It's a class name and the dot. Okay, so here we learned a new one called default method. Okay, so it's can be defined in interface. So you need to have the keyword default, okay? And the public accessibility, visibility is also optional. And it must be implemented. Okay, keep that in mind. So here it summarize the keyword optional, that visibility of the interface itself, method, and constants implicitly public, and the interface method signature abstract, okay? And interface constant are always implicit, static, and final. Okay, and previously we mentioned static and default method. Okay, so let's do a comparison, okay, between these two methods. So the static method, the purpose is share apparent functionality across descendants. Okay, so because it doesn't belong to any specific object, so it's shared, okay, by all objects. So basically, it's owned by the class. So we say it's a share a parent functionality, share a parent functionality, okay, across descendants, okay. And the default method, so it's share a dynamic functionality across descendants. And so that there is no need to implement the method. Okay, the keyword static, default is default. For static method, there is another key important thing is it cannot be overwritten. Okay, so it's defined in a superclass, or it cannot be overwritten. Default method, it can be overwritten. Okay, can be overwritten. And generally speaking, for interface, to have the default method, its purpose is to provide more flexibility for interface upgrade. Okay, so because sometimes when you first design an interface, you provide the set of methods. Later on, you may find, oh, it may need add some more functionality also belong to this umbrella type, is it? So you add a new method. But just think about if you add a new method and uh, and then all classes implement this interface. Then they also need to be upgraded. Okay, so that can mean compatibility. So that will be too hassle. Is it? So a way to avoid it, and that is that you just provide a default method that's implemented. Then whichever the class implement the interface, they don't need to make the corresponding upgrading for the default method because it's already implemented. But if the class does want to use like this default method or provide its own implementation, yeah, it's still allowed to be overridden, is it? So it provides more flexibility. Flexibility. Okay, so that's the advantage, the benefits for default method. Okay, then next, let's see. We have an example about Java interface. Okay, and in our example, we have three package, processing package. In this package, we have two interface called loadable and more loadable. Both of them are interface. And then we have animal class. It's an abstract class. Okay, so, and it has a subclass pet. This is a concrete class. And we also have another package called apparel, and this is a concrete class. And in this diagram, you can see outfit implement this more loadable interface, and the animal class implement loadable interface. And here we also see more loadable extends loadable interface. Okay, so we will see in our example. Okay, so that's the general description about of this classes and interface. Okay, so kind of get a brief picture about this example. Okay, next, let's take a shorter break, okay, regarding the national park. Yeah, so this is a national park and it's a gigantic tree, okay. So the tree, the height is about 286 feet, okay. And the diameter is 23.7 feet. So you can imagine how big the tree is. And the years, so the age of the tree is also very impressive. Okay, it's a 1,500 years old tree. Okay, yeah, so that's the tree from this national park. And here are more trees, okay, in the national park. So yeah, uh, can you guess what the national park it is? Okay, that's the basic information for this lecture. See you in the next lecture.